I'm given a quadrilateral with points A, B, C, and D, and I want to know if this quadrilateral is a trapezoid, and if this quadrilateral, if it's a trapezoid, if it is an isosceles trapezoid. So first I have to follow the trapezoid definition. And the trapezoid definition states that if a quadrilateral is a trapezoid, then one pair of opposite sides are parallel. So as I draw in my sides of my trapezoid, I'm looking for ones that appear to be parallel. And just by the looks of things, A, B, and CD look like they might be parallel. But AD and BC certainly don't look like they are. So I'm going to verify algebraically whether or not AB and CD are parallel. So first, I'm going to look at the slope of AB. So to get from A to B, I first have to go up 1, 2, 3, 4, 5, and over backwards 1, 2, 3, 4, 5. So since I had to go backwards, my slope is negative. It's negative 5, or 5 over negative 5, so the slope would be negative 1. Now, I need to think about the slope of CD. So to get from C to D, I have to think about the rise over the run. So I'm going down 1, 1, 2, 3, and over 1, 2, 3. So since I went down, my slope is negative. Negative 3 over 3 is negative 1 as well. So I have one pair of sides that are parallel. They have the same slope. So this verifies that, in fact, we are a trapezoid. Now, to determine if we're an isosceles trapezoid, the legs need to be the same. So I got to think about the length of AD and BC, which means I'm going to have to use the distance formula or the Pythagorean theorem. So comparing A and D first, A is a 0.50, D is a 0.74. The distance between 5 and 7 is 2, so that's 2 squared, plus the distance between 0 and 4, that would be 4 squared. Remembering that in the distance formula, I'm going to have to square root at the end. So 2 squared is 4, 4 squared is 16, 4 plus 16 is 20, so the square root of 20 would be my answer. So that's the length of AD. Now let's look at the length of BC. If it's an isosceles trapezoid, then BC and AD should be the same. So the distance between 0 and 4, the x values would be 4. So that 4 squared goes in my distance formula, plus the distance between 5 and 7 is 2. So 2 squared in my distance formula, remembering that at the end I'm going to have to square root. And I have, just like before, I have 4 squared, which is 16, plus 2 squared, which is 4. So that's 20, the square root of 20. So AD and BC are the same. They measure the same amount. So I can confirm that this is in fact an isosceles trapezoid because there is one pair of parallel sides and one pair of congruent sides.